Can we start? Good afternoon to all of you. Eminent senior signal engineers who are sitting with us, who have spent more than 50 years in the field of railway signaling. My young, committed, budding signal engineers who are sitting here, and the ever supportive industry counterparts who are also with us today. During the course of tea, I was requested to clarify certain issues about the modernization project. And therefore, before I go to this subject, which has been very adequately and aptly covered by Mr. Sami Reddy and Mr. S.K. Viswas, I would like to only add a last area which is more important from the angle of delivery of the service. I will call predictive maintenance as a service. That I will talk about later. But first of all, certain issues were raised by the only ETCS representations were made. First one was about the spectrum, and you heard loud and clear what was mentioned by the chairman of the board today. And we have been after this for the last 8 months now. Cabinet note has been sent to the concerned ministry. The discussions are on, and to today's development, I think the issue is very clearly understood. But even in that case, if in case it doesn't come through, we have got a backup plan, and we will be using the spot frequencies available to us with the desired bandwidth for only the ETC's application, because you will not be able to deliver the broadband services on that kind of a bandwidth. Second issue is about the interlocking issue, which was mentioned. Now, as far as the interlocking is concerned, as I have clarified in the previous conference also, the entire project is a design-build contract. So you are free to offer what you want. That will be evaluated by the tender committee. You are suggesting a single interlocking, which can be controlling all the 16 to 18 stations. Then you are free to offer it, because we are not, whatever we have specified in the bill of quantities or bill of material is only indicative for the purpose of working out some costs. So that there has to be a cost mentioned in the bid document. And therefore, I would say that the design-build contract will decide what are the what is your design, what is your offer based on that, and if it is cost effective, there is no reason for refusing it. The only requirement today is that electronic interlocking has to be approved by RDSO, or is in the process of approval of RDSO before installation. Number 3 issue is about the operational issues, which will be quite extensive, and this issue has already been flagged at the level of the relay board, and we have already formed a technology group within REL to work out all the issues which are linked to operations. And that is why all the operating principles, signaling interlocking principles, and the driver standard operating procedures will flow from the REL. And that will enforce that the countrywide interoperability requirements do not suffer on that account. The commissioning schedule, as you mentioned, 36 to 48 months, we are considering it. I think it is likely to become 30 months, which is under consideration. And as far as the civil works are concerned, civil works are very important, very small component of the project, but they are critical to the project. And that's why they have to be integral part of this complete design project. I hope this clarifies most of the issues which was raised in the ETC's presentation. Now, coming back to the issue of condition monitoring. 25 years back, the signature what Mr. Sami Reddy had shown it to you was measured by me in Gwalior. In the Gwalior RRIAR, the signature of the point machine was measured and given to electronics. And we are still struggling to implement that signature. The signature has a lot of things. It is the ECG of your point machine. It tells you what can go wrong with the point machine. And that is why we believe now that with the REL being formed, that the Railtel Enterprise Limited, which is a fully owned subsidiary of Railtel, we believe that there has to be a focal point for delivery of this service. I'm talking predictive maintenance as a service. I do not want the Indian Railways to be made responsible for more hardware to be made, more support to be given. I will give you service at per function cost. Maybe it could be 100 rupees per function per month or whatever. And then the function means each point is a function, each signal is a function, each battery system is a function, power supply is a function. If you have got 5,000 functions, you can pay me monthly or quarterly or whatever. But I will tell you much in advance when it is likely to fail. So this example is being given often that for the last 50 years, there's no accident and no delays on the Shinkansen. How it has happened, why it has happened, the reason is very simple. Real-time condition monitoring. We are monitoring not only the fixed assets and rolling stock, but we are also monitoring the external factors which affect. And if you know, then the last earthquake struck the Japanese continents. All the high-speed trains were brought to a stop 4 to 5 minutes before the actual earthquake struck the landmass. And that is why the water levels are monitored, the earthquake seismic sensors are monitored, external intervals are monitored, apart from the rolling stock, condition of the bearing, condition of the traction motors, condition of the OHE, condition of the bridges, condition of the rail, everything is monitored. And before it degrades to a level of failure or to an adverse case of unsafe failure, it is monitored and the central OCC knows about it, and accordingly the commands are either dovetailed to the control system or manually given to stop the trains. And the concept is very similar, which has been explained by Sabi Reddy very clearly. First of all, we have to sense the vital parameter, what you intend to monitor. And then, as it degrades, you should be able to predict the likely problems. And based on the prediction, you should be able to activate the mechanism to quick recovery before the component failure disturbs the safe and reliable performance of the system. Now, this first system specification was issued by Camtech in 1993, and that was also presented in Sweden in the conference called Tech 1993. And based on that, you must have seen a lot of point health monitoring systems developed all over the world. And those things were brought into use, but they are far too complex. And what I believe is that the system should be simple enough, but it should be able to deliver the function which is required of the purpose. This is very clearly known to all of them. I think I would like to skip this slide because Mr. Sabi Reddy has explained it very clearly. Now I'll come to the issue of external interference. This also is vulnerable. Apart from the degradation parameters, we have got a severe problem in this country about outsiders trying to damage or pilfer, or heavy rains, rising water levels, abnormal discharge in from the dams, earthquakes, functioning of tracks, bridges. I'm not only talking of for signaling only, I'm talking of all the systems which are there. That is why Railtel Enterprise Limited has a role there, that we not only monitor signaling, but we also monitor rolling stock, coaches, wagons, bridges, and rails also. Now, as all of us know that for safe train operations, all the vital parameters have to be under control within the specified limits. If they go beyond the limits, if they degrade beyond the limits, then obviously it will lead to a failure situation. And that is what we intend to prevent. Now today, what happens, today's scenario is we come to know about a failure when it has taken place. And after it has taken place, there's a response time of the person, the controller or the station master. He notices when he operates that function. And after that, he informs the maintainer, and then after that, the maintainer goes to the site, and then thereafter, he finds his own method of restoring it. All this leads to a very large MTTR. I'm trying to work back in time. Before that situation of failure is reached, we should be able to, I'll explain with the graphic of that. This is the graphic. This is reactive is basically built on maintenance. When the system fails, it's very, very expensive. Repairs and costs are very high because it is it happens suddenly, and you are not prepared for that. Maximum cost due to impact on train services and cancellation. If whatever we are doing today from the angle of preventive or the time-based maintenance is also not very, very cost effective, and I think honestly we are trying to maintain the system, and you must have also noticed during your own working in the field that the day the point is maintained, on the very next day the point fails, because we have a set of periodicity of maintaining the point every 7 days or 10 days or 15 days. So that kind of a interference is not really called for and not required, and therefore there is a very clear need of predictive maintenance, which is an optimum way of maintaining systems. That before the parameter degrades to a level of failure, you are able to detect it, inform the concerned maintenance team in that form, and if there is no response, there is an alert to the next escalated level, and then if there is no response, then the controller comes into the picture, who is made to talk to the person inside, and that is the three stages of alertness or alert submission, which are being created, so that we are able to go to the situation of zero defect. And the morning member tracks mentioned about this very important word: zero failure, zero accidents. And that is achievable only through three strategies. Number one is, I think RDS is working on it. Number one is a very robust specification. Number two, also RDS is working on it. That is the redundancy in all the designs. And number three is the condition-based predictive methods. Now, I will give a small example that I should be able to tell the maintainer in time. This is an example of a machine, but the prediction time is of the order of days. I'm talking of the prediction time of the order of less than a week. I should be able to tell my maintenance team in time that something is going to happen at for point number 75, because the health monitoring unit of point number 75 of the station is showing some degradation either at the beginning of the stroke or at the end of the stroke or during the operation of the stroke. And with more algorithm being there now, with more precise data being available now, and the strength of the data processing, the data connectivity, and the sensors available now in terms of technology, you can even convey to the people in the field that how the systems have to be maintained. And therefore, that is the strategy towards. And this particular service we intend to offer to all the Indian Railways, I'll say technicians and supervisors who are working in the field. Fortunately for me, I spent 15 years of my time on maintenance. In fact, that has helped me in getting into the feel of a technician, how technician behaves when there's a failure. And therefore, I believe very strongly that whatever we need to do today is for the technician and the supervisor, because if they perform well, the senior DST performs well, and the CST performs well. And therefore, this is what is the algorithm which was explained very clearly, and some kind of signatures which are available are like this. You have to really analyze them, analyze in the form that you are able to extract the required information, the required content, and deliver it to the concerned maintenance team at the right point, so that they are able to act in time. And there are different scenarios for healthy and faulty conditions of different, for seal leakage, for seal breakage, and seal blocked and all that. The signatures are different, as he was trying to explain, for point machines or for the battery system, or even for the track circuits. Every system gives a signature. Now coming to the issue of Internet of Things. Now today the platform is already laid down for having launching the service with whatever data is available in whatever form it is available. Even if it is delayed, Mr. Viswas is quite worried about it. Even if it is delayed by 5 to 7 seconds, it doesn't matter to me. Because I am trying to predict in a manner that I should be able to tell the people for the next 3 days, 2 days, or maybe less than 24 hours, what is likely to going to happen or what is going to happen. And therefore, this is important. And Internet of Things, as it was explained, the core thing is the sensor. If the sensor gives the right data, which has to be captured automatically at source, and that the data processing, data transmission, and thereafter the top layer, which is the application layer, on which we intend to work along with our business partners and electronics, so that we are able to deliver the service. This is the reference model, and this I think is very clearly. This is I put it in different manner. The bottommost is the edge layer where the data is getting collected. And then you are having some kind of edge processing, and later on, ultimately, when you go to the highest level, you are able to extract the information of the data and use that information for the purpose of fruitful utilization by the maintenance team in the field. And this particular, the bottom layer is already there. We are working on the top layer, and the top layer will be integral part of RailTel, because RailTel has got its own data center. RailTel has got a very strong, complex, strong connectivity all over the country. The data which is available in the division servers could be dumped into the servers of the data center of RailTel, and there then application layer, which is based on a combination of the data available, the degradation algorithms, and the machine learning tools which are available today. You can be conveyed that what is going to happen, and that can be in case of emerging alerts. The first alert will go to the technician and the supervisor automatically. And if there's no response in the next 3 hours and the degradation continues, then the second alert goes to the higher level, that is supervisor and the officer in charge. And if in spite of that, if nothing happens after 6 to 8 hours, the section controller through our call center will be alerted that something is going to happen at so and so location. Please go there, otherwise the system is going to collapse. Now, I'm not restricting REL's role only in the field of railway signaling. We are wanting to focus on rolling stock. We are having our business partners working on bogie monitoring system. We are wanting to work on traction, motor monitoring systems. There are a lot of systems can monitor similarly for OHE and the B-way, bridges and structures and rails also. Incidentally, on NCR, some work has been done. In fact, the fiber sensing system, which is now emerging from Fosher, that can also form an input to the system, because that can give you a very, very clear indication about a wheel flat. That can give you a very clear indication about many of the possibilities of rail fracture. And those things, if you are linked to the control center, then you can control that situation and avoid at least one derailment. Similarly, we have put a hot box detector at Chunar, and that could be linked to this. We have got a rail monitoring system, which is having a USFP transcript and a receiver. Those signals are coming into the system, and then you can have a holistic view in the OCC with the concerned carriage controller, driving controller, PV controller, signal controller. They can be watching the systems and be activated automatically by the system, which is the application layer, which is under development. Incidentally, I mentioned for signaling only. Remember, SNT in the morning mentioned about 2 projects, 2 railways, in fact, not project, 2 railways being advised to take up this project of predictive maintenance for signaling. And we have requested the CSTs. We have given our proposal to them. CST of East Coast Railway and CST of Northwestern Railway. They will be shortly giving us the project, and we will be delivering the POC in the next 6 months to them. And once the POC successful, as was mentioned by Mr. Kashinath, we are going to get it countrywide. And I'm again repeating, predictive maintenance for signaling as a service. This is what could be the indicative diagram for that. This is anyway the base system which is available. We can develop more sensors and more systems which are required for more comprehensive predictive maintenance. And let me also explain to you one more thing. Today, the number of signal failures on Indian Railways is 1,20,000. Now, even if this system makes a dent of 30%, it's going to make a significant amount of saving and very substantial improvement in performance. And that itself is enough money to recover the cost of the investment into this area. Now I'll come to this last point, which I think is what he was mentioning about the digital twin. I call it augmented reality. The issue is, you have told him that point number 75 is going to fail. And now what next? So now this augmented reality is a tool which is on your smartphone or on the iPad. You just open your camera and focus it on the device. And it will straight away pick up the database. From the database, it will tell you the condition of this device, including how to repair it, how to adjust it, how to maintain it. And it will be very clear. I think my words will not be enough, but I think you can see in this video. I'll go through this video. We can look at this video. This video is very clear. Yeah.
नहीं हो रहा अगर लिंक लिंक होगा आपके मीडिया आना होगा पेन ड्राइव में
Anyway, this particular when you show your device to the, for example, point machine, the point machine data signature is coming into it now. It is the moment you show on the image, the moment you show on the image, you will straight away pick up here. This is the locking call. This is the adjuster. This is the machine, or this is the carbon brushes. The moment you and the corresponding the data is coming from the system of the degradation in the parameter, and it is telling you where the fault is. Now, this particular augmented reality is okay for the purpose of for attending the failure, because he is clearly guided to the point at which the entire thing has to be attended, and how it has to be attended. That also it comes out, how the bolt has to be opened, how the bolt has to be tightened, what bolt has to be tightened, in what direction it has to be tightened. All this comes out automatically, and this requires a lot of content development work along with point machine, which is we are doing along with Ghaziabad training school. And our business partners, and our we have got a team of IT experts within REL. Now they are working on this concept. They will tell you how it has to be done, because you must know very clearly that our technicians level today is not at the level which it's supposed to be. Anyway. So what I was trying to say that this particular tool of augmented reality can help you in physically not only attending the failure, but also the process of attending the failure. At the same time, being guided by what is happening what is happening to the different parameters of the particular point machines. The same particular tool can also be used for the purpose of training for anybody, anytime, anywhere. And this particular work is being done in Railtel Enterprise Limited, which I believe that could be useful in our training schools, and they can be also made available online, so people that can be used effectively by them. I'm only trying to say this because Chairman Railway Board also mentioned about innovations in maintenance strategies, and this is what is the focus area for that. And with this, I believe that we can slowly and steadily move towards a zero defect strategy, which is the base for optimized operations and reduced number of civil failures. Thank you so much.
Thank you, sir. Next up, we have Mr. A.K. Chopra, who will be speaking on challenges to SMT engineers. Sir.
Finally, here.
Yes.
नेट नहीं करता।
Mr. Pradeep, DG NAIR, and my colleagues. And first, thank you for inviting me here for this discussion. I picked up this topic of challenges for the assistant engineers simply because now we have got a member of our own, and the things have changed, and things are supposed to change. That's why I felt that initially we used to blame, hey, what can we do? We don't have our member. We are not being listened to, or our advice is not being acted upon. So now we have no excuse. And having taken this responsibility, we have to start a new challenge with us. I'll just give you these 3 slides, which was given by a retired member traffic recently. Recently means last month in one of the presentations, and these slides are from him. Surprisingly, he said, IR is now more passenger-oriented railway. Now, we have been all our life, we have been listening that the freight is the most important, but first time he said the passenger is equally important. The lower class passengers is a traffic loss, is well known, but he said upper class passenger traffic is remunerative. It was surprised. Then he said the upper class passenger traffic is only 1.85% of the total traffic, and it is not growing. Now this is the chart which he has given. At bottom you find that the upper class passenger 1.85%. He's been steadily roaming around and is not grown. Suburban traffic is very high. Other traffic is just like that. Now, this pie chart shows that 1.85% of the upper class is giving you 32.23% of the revenue of the passenger traffic, which is startling. So, what does it mean? That one, the traffic is not growing, and upper class passenger is giving you a revenue of 32.23%. After that, another bombshell was given. IR refunds 28 crores every day due to cancellation of reservation for IR's inability to provide confirmed reservation. Yearly opportunity loss is 10,000 crores, which was a very, very revealing information. I asked him, if the upper class passenger is a paying proposition, then where is the problem? Why are you not running more trains? Why are you refunding 28 crores every day? Because you don't have a capacity. That's the problem. I said you don't run the trains. If you run the trains, you can complain that if your traffic is not growing, if it's going empty. It's not so. Today I just asked you how many people have come here to this place. Just can you raise your hand? How many of you have come by here to this place? What are them? This is the revenue lost to the Indian Railways. I stated, put it like this. Now, this is the hypothesis. IR is suffering due to line capacity constraints and underutilization of the rolling stock. I say underutilization of rolling stock that large number of trains are running between 7 hours to 10 hours a day, and for the balance 14 hours they are stabling in the yard waiting for the next train. So that is a stable rolling stock doesn't earn money. Secondly, no prioritization for the enhancing of the line capacity by better signaling system and communication technologies. It has never been prioritized. Somebody decides you have double line, you have double line. Somebody decides you have third line, you have third line. Nobody asks the signal engineers what exactly can be done. For the last 3-4 years, I have been writing to the various people, including the minister, that Indian Railway must have a vision statement that Indian Railway will carry all the offered freight, passenger, parcel traffic efficiently, safely, and to the full satisfaction of the customers. You can't have a shop where the customer comes to you, you say, hey, I don't have a place, I don't have goods for you, please go to the by air or by pedal or by car or whatever you want. Mere paas nahi. This is not the way to run the commercial organization. So, if you have this vision statement that all the passenger traffic or freight traffic or parcel traffic which is coming to us will not allow it to go back. It must be captured, it must be carried by us because it is our job. Having done so, now I will say what is the mission for SLT engineers. We have to advise all the policy makers in one voice. Why I say one voice? Because during my career I have been saying no two signal engineers agree with each other. Everybody has got his own opinion. And they say I am the best, he is the other one is a fool. Now I'll say when we have got our own member, he understands our requirements. To your member, tell him what you want to say. Give all your opinions and all your options. And once a decision is taken, it should be followed in one voice throughout the country. And every division, every relay should know this is what we want to do and this is what we want to achieve. So these are the tasks ahead for us. 4 categories I mentioned: signal engineers, telecom engineers, RDSO, and associated industry. All of us are here. We'll take one by one. The signal engineers planning for the land capacity. The computer simulation is now available in a big way to precisely guide how much line capacity can be enhanced. Earlier, it was only we thought international computer simulation is available. Last December, I offered to Konkan Railway that they were going for the partial doubling for 5,000 crores. I suggested you must go for the CTC and automatic block of the single link section, and you should be able to run more trains. And computer simulation is feasible. But I said, according to my knowledge, it was only available from abroad, maybe costing 1.5 crores or so. But surprisingly, Director RV Associates of Hyderabad, Director, he told me, he said, we have got a computer simulator with us from Australia, and I'll do it free for Konkan. And we are returned to it, and currently we are working on this. I hope by next month, results will be known. CSD Konkan is here. He has been also one of the helpful figures to us. If we want to achieve this and prove that computer simulation is the in thing we have to adopt. Second, before going for any double line, third line or quarter plane, I will say we must ask for the computer simulation as to what is the current line capacity available, not by the traffic what they are giving. Prove it from computers, this is what is going to happen. And then by whatever changes you want to do, either by the automatic block or by the CTC or by the double line, you compare the line capacity and find out and then take a decision. This is another hypothesis I want to say. We have not tried it earlier, but I am of the opinion that we must remove all our block instruments, whether it's single line or double line, where block to except counter-cycling provided. Why we should have this one box for the block pulling and all this thing? Straight away go to the video, press the buttons, prove electrically, and let the line clear be given, and that's it. I have successfully done it on Badrat Dhamra section, where Investors was involved, and we have is the first CTC we commissioned with electronic interlocking in the strategy, and it's functional since 2011. This is the time we must remove, because this will improve our reliability also, and system reliability will be one. But I request RDSO, they must work out in it and give your directions, this has to be done. Second, centralized traffic control and with train management system and artificial intelligence for optimizing operations. This has to be done. And I am very happy that at least in Tripura, they have realized that the CTC is one which can help us. But the Tripura CTC has got a handicap. For every 7 or 8 stations, they are putting 2 operators to operate the buttons. What is required is, you should have all the software systems available, all the trains have to be prioritization should be available, and with the actual running of the trains, prioritization should be done automatically, and CTC operator has to do nothing. It should only do when there is a crisis. Otherwise, nothing is required. That will make you more optimization. But if you do CTC on the single line section, it is important that single line, these crossing stations must have more loop lines. Only then the automatic block will be effective. You can't have three loop lines or 1 loop line and then say you have CTC and automatic will fail. What are you consider 3 or 4 or 5, so that you are able to hold the more number of trains at the station, that becomes more important. Then systematic required automatic block system of double line and single line sections. When you go for the double line sections, the holding yards must have more capacity, because otherwise the double line will become ineffective. You have to push one train after the other, and the system has to be designed in a manner that you should be able to push one after the other. This gives you another area that for each yard, a separate simulation has to be done. There is software is available throughout the world, wherefore the yard simulations are done for taking care of all sheltering operations and everything, and then come to a conclusion as to what exactly is required for this. Here I would like the board to think that the GR needs to be modified for the double line automatic block. See, GR provides in a single line, the line must be clear from one automatic block to the next without overlap is available. But in the double line, you add 120 meter overlap for in the double line section. That has to go. Because we have got, if a single line can function, why it became a single line is because of the Gorakhpur-Chhapra section, where the we provided this APB working. There was no overlap kept in the single line section because it will become more expensive. But the double line, after once the direction is established, the trains are following each other. Why you have this overlap? What for? It doesn't serve any purpose. It's only increasing your costs. More so, you have got 1 kilometer distance, train length is 750 meters. Naturally, 250 meters are available behind you. And possibility of a driver overshooting and hitting is very, very remote. So this GR portion needs to be effectively changed. Other is a point, now the board has decided that the ETCL level 2 should be provided all over Indian levels. And if it is provided, the automatic signaling, virtual automatic signaling block, as Mr. Arun has also mentioned earlier, will become automatically along with it. So we may economize on this cost that having ETCL level 2 and the automatic block on the CTC we put together, it will be much more economical. This is my firm opinion that say no to third line projects is a total waste of money. Because by double line section, normally we run about 50-55 trains. If you get automatic block, you can run 100 trains. But you add a third line, treat third line like a single line. In single line, you normally run about 22 trains each way. But you add third line with a double line, you will not be able to add more than 15 to 16 trains because your press crossing of the movements the operating people do, it will not be useful. So, third line, we are unnecessarily wasting money and resources, and it's taking a lot of time to do. Instead of that, I should go for the partial quadrupling. Now the partial quadrupling, I said, convert third line project into partial quadrupling, wherever the longer block sections are there, say for 12 kilometers, 50 kilometers, extend the loop line by 1 kilometer, 2 kilometers into the block section, and operate the points through the object controller which are available, and operate everything from the remote from the CTC, and have your automatic signaling on all the lines. So if a slow train is there, put it on the loop line, let it continue to move, and a faster train can come on the through trains, and by the time it comes, the slow train will follow. And as the traffic grows, you can extend the block sections, and one fine day you will have a quadrupling available with slow, fast, fast, slow. And there is a proper investment has been made out of this. Now this is another area where civil engineers have failed miserably. We don't do any planning at all, except for making a signaling plan and maybe the control chart in the headquarters. Rest is all left to the signal inspector of the sector. When I was working in the AECOM for last 4 or 5 years back, I took on the challenge of having design set up in AECOM from Network Rail UK. And 23 engineers were recruited who are IRC license holders, and we put them onto the job. Then I said, let me also learn what design they are doing, because we want to see. To my surprise, they said they are only having a location box design, the track bonding design, and the cable line design. I said, look, for this design, we have got so many engineers there, people are investing. Three level check here, 2 level check in the UK, 1 level check in the network rail, and then it's commission. I said, we never did this in our railways. We simply asked for the SI by location box laga dijiye and go ahead. So this is where we lack. And because of this planning, installation is poor, the failure rates are higher, and the time taken for installation is too much. This has to be rethought. No standardization. So detailed planning, system design, and during detailed planning, we have to visualize all the problems and the resolution in advance. This is most important. This somebody has mentioned earlier also that we have to plan the project in such a way that the project completed before time. There should be no cost and time overrun. Now the automatic block work, which has CSTI got its sanction in 98 and 99 for Virat Ahmedabad section, was completed in 2011. It was my vision that it would have been done in 2 3 years' time, maybe 2003, 2004. It took so many years to complete. It loses its relevance. We as a civil engineer have to know that if a project is taken, sanctioned, do the proper planning and systematic planning to make sure that there is no cost overrun. And I think no signaling project should last for more than 2 to 3 years. If you plan it properly, it will happen. And there is no reason why it cannot be done. And then lastly, when a changeover has to be done from, say, one signaling system to another signaling system, we are used to, 10 days, 15 days of non-interlock working. I think it should be done in hours and not in days. And people are surprised and say, no, it is not possible. I say it is possible because as DST construction in Ahmedabad, I have done Masana RRI, which is 70 points, 70 track circuits, 5 directions in 6.5 hours of changeover. This is still all India record, nobody has broken. I am saying 6.5 hours, nobody has broken. And you please have that, because of that time, of course, subsequently Delhi Mail was done for 24 hours. And Calcutta Howrah has been done. But the problem is that for doing this, lot of planning is required. And we are not willing to do that planning. If you do that planning, your traffic people will be very happy. They will be willing to say, okay, please do the changes, we'll be very happy to organize them. This has to be in our blood. This is another area which we are lacking. All the electronic interlocking and this Excel counter which are coming up, we are all saying, give it to AMC, to the original equipment manufacturers. And we are our engineers and our supervisors and the staff are lacked the know of this. I personally feel that we must give training for software to all the engineers, either in research or to the OEMs, wherever the work is there. We should do all the changes ourselves. We should be confident of this. This is very important for our survival. Otherwise, we'll become only a contract order and contract maintenance people. So coming to the communication portion. Now, Realtel has already set up a good amount of bandwidth available, and this needs to be fully exploited. First, for the 10 mobile communication. Second, it should be excellent backup for the ETCS level 2 project, which is on. And thirdly, for computerized train reservation by providing online checking of reserved accommodation by TTs with the handheld units. This when I was MD Realtel, at that time I proposed we should do it. That time the minister said that, आप तो TTs लोगों के पेट पे लात मार दो, so this should not applicable. But then today time is come that after the chart is prepared, all checking should be done by this computer. It should be online compared, and then there's no further manipulation required by this. We will be optimizing the utilization of the systems. Free Wi-Fi at all stations. This, of course, Realtel is doing. But I think they should link it with the PNR of the tickets rather than giving totally free. Because totally free means it is going to be misused badly by so many people. This also been talked, the CCTV coverage at all platforms, entry, exit points, LC gates, supported by robust public address system. Simply putting CCTV cameras is not enough. You have to have the public address system. So supposing a CCTV monitor is finding something wrong, it should be immediately able to announce on the public address, you are doing something wrong, we are calling the police and are going to be apprehended. That fear has to be there. The passenger information system like platform indicators, coach guidance system, and train running position linked with the data numbers. We had put it, but it has been put into disuse from 2008. At least I started having this from Mathura to Godhra. For 5 control sections it was done. Automatic control charting, we are giving precise information of the train where the train is. This has been discontinued by for the pressure from the traffic department. I think this needs to be looked into once again. Then entertainment in the trains. Now see, if we are going to run more number of trains, if the trains are running empty, you have to do the marketing, or you have to provide more services to the passengers to attract them to the trains. So we should have live TV coverage inside the trains, like aeroplanes cannot do it, but you can do it. And actively participate in making railways a paperless organization. I was told by CMD Realtel that the board has already given the Realtel this responsibility for going for the enterprise resource planning to reduce the files and make it paperless working is a step in the right direction. And our communication engineers should fully participate into this activity. Now coming to the RDSO. This is the area where the RDSO has been a neglected organization according to my views. New ideas which are coming to anybody's mind, RDSO must look into it very positively and speedily. Our SLT director in the RDSO has done a wonderful job in these 4 areas of integrity power supply with mid-90s, data loggers, LEDs, and block room extra counters. They are all indigenous developed and very well accepted by the Indian Railways throughout. Another area which I feel is that we should explore indigenous CDC system, as it need not be SIL 4 compliant. Somebody mentioned it should be SIL 0 in the morning. Why not we have indigenous? Why go on looking for people from outside to help us with CDC? We can develop our own. Safety aspects are taken care by the station signaling system. So CDC is just simply giving commands from remote and operating it. Maybe artists would like to work out it. It may be a good idea to have a due consideration of this. Another area is the RDSO needs to be revamped. It's totally relooked. Idea being is that, if you don't know, is the normal perception in our times. Maybe something has changed, I don't know. If you don't want something, you say, ask RDSO to have a look. That will not come back. So this perception has to change. If an RDSO has some project in their hand, like I gave an example of the GST Council is totally new. And every 2 months, people used to meet, sit down, find out what are the solutions, and come to a conclusion. And wonderfully, they have come to some agreement on this. Same thing can be adopted by the RDSO, that if you have something in our mind as a project, take it seriously, meet regularly, sort it out, and see to it that it is implemented in a short period of time. And the RDSO officers should be exposed to the latest technologies all over the world. Let them go wherever they want, find out what are the solutions, and come up with this is what can be implemented in our Indian railways. This is advice to the original equipment manufacturers. Many of us are here. Please tell us what are the latest technology available in the world over which we can adopt in the Indian railways. We have to be open for this. It's not that somebody tells and comes up. Let it come from the OEMs. This is what is available, and this is what will be useful for us, and we have it. Secondly, manufacture as much in India as possible. Only then the volume will get generated if the equipment is manufactured in the country. Otherwise, no. And thirdly, reduce the prices with increase in the volumes. I am told that the large number of electronic interlocking prices have gone up very high. And it is not a good arrangement. If it is happening, all of us have to think how to reduce the prices, because electronic prices are going down, they cannot go up. If they go up by making a cartelization, then the thing will happen like Kingfisher in the Jet Airways that everybody should do. Other area is that thanks to Mr. Akhil that he took a lot of initiative for the IRST license. It has come up in a big way that all the original manufacturers should go for the license for their staff for the design, installation, and the testing. This will enhance the quality of our installation, which is very, very important. And as I just mentioned, do not form the cartels to get more profits. Otherwise, railways will be forced to look for other options, maybe from China, Russia, or Poland, or even indigenous. So now same thing for the contractors and the PMCs. Railways should ensure that the contractors have proper qualified staff. They should be indicated in the tender documents. Already board has given some directions. This should be followed. That means again the people should be IRST license holders, qualified, so that we know that this is the person who can do the installation, he can do the testing, he can do this thing. Then only you can rely. So this only today I came to know the IRSTLO has already got 117 applications for licensing, which is now in the process. And I request all of you to please look into this in due course of time, maybe before this year end is closed. these changes may take place, and the people who don't have the licenses may be the losers. And lastly, when you're preparing the tender documents, don't be rigid. Be very careful for the contractors' cash flow issues. A large number of contractors fail because of your rigid conditions in contract documents, and they are not able to handle cash, and they delay and they fail miserably. If their contractors fail, we fail. We have to see that the contractors progress appropriately, and that is very important for our survival. Thank you very much.
Thank you, sir. Thank you very much. Now I'll request Mr. Aslos Basman, Director, Retail Corporation of India Limited, to enlighten us on the issue that connected tracks, LTR, AIN, IOI.
Very good evening, sirs. It would take a lot of guts for me to speak in presence of my first MD, my first maiden director, my first ED marketing, who have given that passion which has driven Railtel till date. I am Ashutosh Vasant. Thanks to NAIR for giving me an EQ. I got a chance to speak in between. Thanks again. I was supposed to speak in the morning, but again, business drives the mayor. So we had a business opportunity in the morning, and which held me back. Thank you very much for giving me this opportunity. I can understand that you have been through a long day. So I would just run through. And sir, I would again like to thank you the passion that with which I had seen you in probation when I came to your office as CSTWR, sir. You were plotting exactly the same thing, sir. Extension of loop lengths. So, but he has been driving this since ages, and we hope to see the light of day. Sir, whenever we speak about Railtel, it never ends, sir. It's in our blood, it's in our DNA, we can't stop. But I think I would limit myself to just the topic today. But sir, as you rightly said, it is very well said that sweat more in practice so that you bleed less in war. What he rightly said, if we can plan things ahead of time, we can create networks or assets which do not fail. We should never get counted as SMT engineers. The first parameter on which we get counted is failures. I think the paradigm has to change. Believe me, we can create networks which do not fail. And these are not an isolation, not idealism, but there have been practical implementations which have not failed. I can name a couple of them for you, like OFC is laid upon Anand Khambat, Gandhidham Bhuj, Palanpur Ahmedabad, Indore Ratlam, Fatehabad Ujjain. These have been ideal networks which have not failed for 7 years, not a single outage, because we put our heart and soul into it in creating assets. Even post-earthquake of 2001, couple of stations which had totally collapsed, we sat on it and created them, and I can promise you, check the records, we had 0 failures. So it is not possible, not an impossible task to do, just a question of commitment which each one of us are capable of doing. Without taking much time, I would just run you through what I wanted to speak about. As sir said, and I believe a lot of the earlier speakers must also have spoken about it, if we can have a ubiquitous communication network which never fails along railway tracks, the world is at your command, sir. There's so many beautiful things to do, whether it is signaling, improving efficiency, improving output of whatever we invest in. So I would just take you through what we have been proposing with the blessings of the board, with Akhil Agarwal sir guiding us. Then we have got LTR coming and taking as light of the day. But the vision is to have this beyond what we are thinking of. You would see that in case of any emergency in the country, all your public communication networks fail. People take it for granted as long as it is working, but the day it fails, you receive flack. After the new CUG got rolled out and there was an accident, there was no communication at site, and we bore the brunt, though we were nowhere in between, but that thing did not work. Similarly, in Fani, the entire network collapsed, but we should clap for ourselves. Our networks did not fail. we should be proud our optical networks did not go down even for a minute backwards. We should be proud of it that the entire East continued to serve all of us together. So I'm just taking you through why we need a continuous network, not just in few sections, but along the complete track, not just for railways, but for the country as a whole, because we are one of the countries who do not have a public safety network. It is a big business opportunity. And the railways crisscross the country wherein we practically connect 70% of the country's population. So along tracks, if we can build a network which does not fail, you can serve the country for all its security, public safety, law and order, and in turn reap rich benefits, as Sir said, about what you can do with railways. I need not talk about it, all of you know about it, but I would definitely like to say one more thing, that you should be proud of the fact that RailTel is the only telecom company under Government of India which continues to be consistently profitable, consistently dividend paying, and consistently debt free. The only telecom company under Government of India, and you own it. We run today, sir, 52,000 kilometers of network. In fact, 52,500 out of 49,000 kilometers is along railway track, and around 2,900, 2,600 kilometers is outside from operators. Similarly, we run 14,000 kilometers of excess networks in cities, out of which 5,000 is owned by us and 9,000 is through various arrangements. That is the excess and reach available to us. This is a challenge which we face whenever large groups of people and devices communicate simultaneously. Almost all the time the networks fail, which is a reality which we all of us experience. And public safety users require a robust and dedicated communication network, which is never supposed to fail. It should be like light or rain or sunlight or air. What is the disadvantage when you use public networks for public safety? You have no control. You cannot prioritize public safety data and general public data. You cannot prioritize, or exclusivity cannot be offered. No means of preempting network usage often results in network blockage jams during incidents, disasters, and emergencies. What is the solution? Which already we are moving towards, but it should not be in patches. It should be entire railway network. The solution is private LTE networks, because it offers emergency services their own express lane on the wireless information superhighway. Connected policeman means a force multiplier. Connectivity, the critical enabler, effective incidents handling, data preemption, detection, monitoring, reaction, resolution, analysis, a seamless and reliable connectivity between security personnel, devices, applications, and systems. No need to overstress, but a fact. And a connected officer, whether it is a railways, a public servant, or anybody, imagine what all we can do. Mission critical, push to talk, need not dial. You can have emergency numbers defined. No need to wait for a call to get through. Identification, you can have body-worn CCTV cameras, you can have geolocation, situation awareness, incident reporting, multimedia apps and services, mobile computing apps and services, dispatch scheduling. In fact, a total turnaround of everything that you do. Why LTE? Again, I think people must have spoken since morning. One of the best spectral efficiency, one of the lowest latency. So if you want to do mission critical applications, this is the best solution. It also not just 4G, upgradable to 5G and beyond, because now most of the devices coming through are programmable. Even our DWDM, which we initially started with 2.5G, 10G, are now 200G, 400G, 800G, just license application based. The hardware remains the same. Mission critical evolution, as you can see, the steps have moved from non-critical to business critical to mission critical. And tomorrow's mission critical, whether it is predictive analysis, real-time video, robot, drones, wearable, interconnected. And this has been adopted the world over. It is not something that we are trying to push, which has not been proven or tested. There have been a number of public safety networks coming across the country. But the challenge is no single pan-India agency to represent the public protection and disaster relief interests. There are so many silos, budgets, different agencies, MHA working separately, we working for our own requirements, child and women welfare department working on their own requirements. Time that we create a common platform and push for railways to come up with a PPDR network. Biggest challenge, spectrum allocation, but with Railways might, Railtel can plug this gap for India, and it can become, once you have a reliable network in place, people might have spoken since morning about it, the world is at your command, you can have an enhancement of work efficiency of your workforce. See, most of the people who are in field, even to give their attendance, they have to depend on somebody. They may have challenges in the sense that the person whom they are reporting to may not mark their presence. You are aware, if you have a ubiquitous network, you can mark people by just geofenced attendance, work assignment, support extension. Somebody lost at site, he can be held. Incidents assignment, app-based real-time inputs, auto-escalation closure. In fact, while driving today morning, I spoke to the SI control who worked with me for my assignment to the Railways 2000. I said, what has changed since then? How does the incidents reporting change? He says, no, only changes. Now everything is flashed to everybody. So there is no time left for anybody to have an escalation matrix. As soon as an incident happens, he says, I post it on the Telegram or on the WhatsApp, and everybody is on the hot seat. Earlier, we had some margin, SI to CSI to AST to DST and something. No, now everybody is on the fire. So I think this can still, and then the reporting, coming back, escalations, still have to see value. We have just implemented a PMS, a performance management system. I would request you to have a look into it. It actually gives you an auto escalation. It gives you an assignment of a job to an individual. The time that person acknowledges, you have an assurance somebody competent has taken care of the problem. And then what all actions have been taken are also recorded. The beauty of the system is you do not have to depend on your own intelligence to say, oh, point number 478, परसों भी fail हुआ था और 10 दिन पहले भी हुआ था तो शायद तक किसी ने केबल मेकर नहीं की. Yeah, there is a problem with the tongue. Now, individual intelligence is no longer required. The system gives you pinpointed areas where the problem is because it gives you an analysis. It also gives you a prediction. I think somebody must have spoken about it. We are trying to do it. One of the test cases in NWR, thankful to CST, NWR, and the GM for having sanctioned a project which we would implement. You would see value because now you can even predict what is likely to fail in the next 10 days, what is likely to go wrong in the next 15 days, what are areas which are hot, which you need to immediately handle. I think we would bring a big relief to our guys down the line because their lives remain as miserable as they have been through ages. If we can use technology and eliminate areas where we bring a level of impact blocking, monitoring, in fact, it has the capability of IoT-based even generating the TA bills. But if you do that, you would invite a lot of trouble in the organization. Otherwise, you can pinpoint working hours of a person in field as you can do with your Apple Watch. Same you can do with every individual, what time spent in field, what time spent in office, how many hours spent out of your headquarter. You can actually generate the complete PMS and MIS. Analytics, prediction, action, KRAs, KPIs, monitoring and reporting. Even your CRs or APRs can stand generated based on your actual performance. Asset tracking, we are one of the richest in terms of assets in Indian Railways. So many asset slides strewn around the network. You can actually track them, stock manage and order. Reliable worksite video relays, support and guidance to people. Onboard life surveillance, analytics and automation of passenger onboarding, as you said, sir. No need for a TT or anything. You come in, your facial recognition can identify repeat users, or you can even help with a barcode, or you can even have a Bluetooth beacon, or you can have so many varieties once the communication is on. IoT-based real-time monitoring of all onboard equipments. No need to unnecessarily put people on job to find out last schedule, last trip, last top-up, everything onboard IoT-based. Onboard entertainment, education, health, even you can promote trading. Who stops you? In fact, if you travel in Shatabdi, Mumbai, Ahmedabad, most of the people are online trading, but they abuse when they do not get the signal. I think you can value add, charge them more. And sir, you can actually lease smart offices, smart workspaces as you drive. People are hiring offices. Somebody on the Rajdhani, you can charge him. I'm giving you a smart office for next 10 hours. You have the best connectivity. You have the best internet service. You have computing available. You have storage available. You have applications on the move available. You can do this. As I said, we look forward to this of helping our brethren get out of the loop of signal failure analysis. We want PNS to come into picture, real-time detection of faults. We just visited the control office in Delhi yesterday. We have tried generating a POC. We'll go ahead and do that and show results. We should not push technology just for the sake of pushing technology, but from the idea of empowering our people. And we intend doing it very strongly. We just analyzed, and this is what exactly a PMS would look like. You can assign tickets. In fact, I would tell you, railways are the railtels, one of the most important users. By end of June, you would be able to log your problems through an online portal. You need not call anybody. You would have a web interface. Whatever you write would generate a ticket. You would have SLAs. You would have TT given, trouble ticket. You would have ETR when it is getting settled. If it does not get settled by that time, it would auto-escalate to the next guy who is supposed to respond. Otherwise, he would have problems. So this is going to come into picture. We are at your service 24/7. You can take note of this toll-free number. It has auto-escalation. You need not run for whom to dial in case of any network issues across country. Just note this number, dial this number, we are at your service. Some milestones which all of us should be proud of. Sir, as you said, e-office has been rolled out ahead of schedule for South Central Railway. In fact, sir, we are fully geared up to take NAIR onto e-office. Everything done, training done, DSC is issued, just a URL creation because we had some server upgradations which had to be done. So next 5 days, we should see. Tomorrow, RailTel goes live on e-office tomorrow morning at 10:30. And as I said, funny, most of the networks failed. Your own network did not fail, it continued to operate. You should be proud, sir. You run the network of 100G for Amazon, Google. We have Facebook soon joining us. So most of the ICPs are on our network. Every cable operator, multi-system operator in the country is on your network. You should be proud. You run the TV systems in the country. Every name the operator is on your network. All prestigious institutes of higher learning, IIT Kanpur just on 10G, IIT Guwahati, IIM Ahmedabad, Space Application Center, Physical Research Laboratory, ISC, Bangalore, name the institute that is on your network. KFON, now we have entered and gone beyond railways. Kerala fiber optic network, Kerala statewide network, Haryana statewide network, Rajasthan network is all with you, and we are growing. You should be proud, sir. Army, Navy, Coast Guard, DRDO, LTRO, the secret labs of defense, ESIC, EPFO, they're just some of the big customers who are on your network. Thank you very much.
Thank you, sir. Thank you very much. With this, we now move to our last session. And
Acha, okay.
Since it seems that Mr. Thiel is going, and we would just like to present the memento before his departure. Just 30 minutes right now. Okay. So.
Either. Take it. सर एक खोल दे सर पैकिंग ये नया मूवमेंट हम लोगों ने
Now I'll request our senior officer, Mr. A.K. Chopra, retired M Signal, please. Next, I'll request Sri Akhil Agrawal sir to please come on the stage. I'll request Sri Sandeep Mathur, AD Signal RDS, please come on the stage. I'll request Mr. Prasant Rao, Director SERGM RCM, please. I'll request Sri Ravi Prakash, Director GTS Sales Group. I'll request Sri Chandrika Prasad, our ex-AM Signal. Request Sri Sambi Reddy, Director MS Electronics, please. I'll request Sri S.K. Vishwas, PCST Central Railway. I'll request Sri Astos Vasan, Director RCI. Okay, now I request our Chinese team, the CRSC team to come on the stage and receive the momentum. May the team come on the stage. So with this, now we'll move to our last. Sir, okay. Now request Astos sir to please come on the stage and receive the memento. Also. Now request Sri Arun Saxena sir, our advisor, senior advisor to Railtel Corporation of India Limited. Thank you, sir. Thank you very much. We really appreciate the effort which all the teams have taken to come here and discuss all the sessions. Now, I'll request our CRSC team to come on the stage. Sri M. Suresh, our own retired AM signal, Sri Jenfeng and C. Jenfeng. Please.
Before the Chinese team takes over and the leadership of Mr. Suresh, I would like to play that video, which was supposed to be one of the concept of augmented reality. How you would. This is first of all, you will be able to locate the part which is defective, and you are just putting your mobile telephone or the iPad in front of the part. It locates the part which is defective based on the data on the failure which is available real time. Once you locate the part, then you will be able to locate what is the fault in that and what is the procedure for changing it. Then you inspect the part. Now this is the real-time data which is coming on the valve pressure. Similar data can come on your parameters for your systems like batteries or currents or voltages or signatures on that particular part. After you have inspected the part, then and this is all being visual to the technician or supervisor. Once he sees that, now he is able to repair it, and for how to repair it, the part is to be replaced. What is the strategy for that? First of all, the valve has to be closed. Then you have to open the bolts, and then the part has to be taken out. This is rechecked once again, and this is all virtual. Nothing has been done so at site. Now this person knows what is to be done now. This is again rechecked, and after he has rechecked, once he physically replaces the part, after that the work order generated, which is linked to your database again. That this particular part was replaced on so-and-so date, and after that the work order is closed. That means your database knows that this particular component or point machine or battery or power supply was attended on so-and-so date, much in time. And this is what the verify the work is completed. That is, this is called the augmented reality, which we are working on, and we're starting with the point machine first. Thank you so much. I would request Mr. Suresh to please come. Thank you.
Thank you very much. My very special thanks to Mr. Pradeep Kumar, Director General NAIR, for having given this opportunity to be here amongst you. Very good evening to all of you. Well, since morning, everybody, most of us spoke about Shinkansen. Even I had the opportunity to go to Japan about 3 decades back, and there it was noticed that the punctuality was monitored in seconds. And even today, we said a train running half an hour late. Oh, train running half an hour late is okay, it's running on time. Well, that's the kind of punctuality what we have, and the delays and all we'll have to sort of make good. We heard Frosher, of course, they have left, and they talked about no holes in the rails to be drilled for fixing the equipment. Well, another thing, very good important thing in that is there is no wayside electronics to be maintained inside. So if we have to improve our maintenance, we have to naturally have whatever systems we provide, it has to be less maintenance sort of intensive. Mr. Sandeep Mathur, of course, spoke about EI. He said earthing was missing, and that's why the whole EI failed. When I was working in RDSO, there was a presentation going on. Those days we had this OHP, and the presentation topic was why projects fail. And as soon as the presentation was about to start, the bulb failed. I mean, the bulb fused. And after that, there was no presentation. Similarly, what I'm trying to say is, our father of nation, he had mentioned one very important thing which is there in IRISET also. It says, howsoever insignificant thing you do, give it the same importance as you would give to a major thing. Because more often than not, your performance will be judged by the outcome of those small things. So it's very, very important that we do all small things with the same importance as you would do a big thing. And of course, Mr. Akhtar has just left. He was talking about fear of the unknown in the morning. Fear is nothing but nowadays we have to face everything and rejoice. So I think that's most of the SNT engineers now are doing. Like what we heard, all the speakers, they said, so confident, so very nice. It was very nice to see all the speakers talk with a lot of confidence. So this is the kind of confidence SNT engineers have. They have developed, and I'm very sure in the days to come, we'll all have very budding SNT engineers coming with a lot of confidence. And coming back to CRSC, yes, CRSCD has got is the Signal Railway Corporation Research Group. They have got a project on EDFC2. They are doing the signaling and telecom work from Kanpur to Mughalsarai. The electronic interlocking is being supplied by them. There are 212 stations, and of course, a lot of object controllers at various 62 location huts. The electronic interlocking is presently undergoing type tests. Like Mr. Mathu mentioned, that we have got 4 approved suppliers, and we have to have more. And hopefully, they also apply for the RESO in the near future. And Mr. Sabir Reddy mentioned there are certain features in the EI of CRSCD which none of the other approved suppliers has. I'm very sure that the progress will also move fast. Well, China, has 132,000 route kilometers of railways, out of which 70% is automatic signaling. They have 32,000 route kilometers of high-speed rail, and out of which 16,000 route kilometers has been provided with CTCS3, as they call it, Chinese Train Control System 3, which is equivalent to PTCS level 2. And 16,000 kilometers of CTCS3, the 90% of the equipment has been provided by CRSCD, and that's the market share they command, and that's why the leaders in the signaling and telecom market in China. They have recently commissioned a project in Kenya, right from Mombasa to Nairobi. It's a distance of about 480 kilometers. The EIs have been provided by them. The Kenyan government has praised the Chinese government because they was funded by the Chinese government. It has given indirect employment to 46,000 people and direct employment to 20,000 people. So that's the kind of project they have done. They also have projects in Indonesia and Serbia. Well, more of it and others from my colleague, Mr. Sri and Mr. Sri. Thank you very much.
Okay, thanks. First, I don't want to repeat what Ms. Sri have said. I have the same opinion, okay. But anyway, I should say thanks to Sir because you arranged this meeting, this workshop. I found that so many excellent presentations and ideas, and I think it's a good chance for all of us to learn and improve. So for this part, I think I should say thanks again. Now I want to introduce my team. Actually, my team first in the Suresh. They gave me so many guidance and suggestion, and normally this suggestion is helpful for me. Part of the suggestion is very helpful. And the second part is Mr. Peng. He's my personal coach, and actually he is our chief consultant for CICD. Also, he was the SNT chairman for Hong Kong Metro. The third one is Mr. Trey, my expert, and he will introduce our presentation. Me, my name is Qi Yinliang. Normally, my friend called me Qi. It's very easy. I'm deputy director for marketing, and also I'm authorized representative for our project. It means the DFCC project CP204. It's normally like SNT EPC project. So normally I will stay in Allahabad and sometime in Delhi. Now, what I want to say that after 2.5 years, I must say that I like India. Yeah, so long time, but it's true. Okay. Because that I think that the person is professional and candid for me, and the culture is charming, and the food is amazing. But in another side, that even after 2.5 years, I found that so many questions about CRCD, with CRCD, what they have done, what they have doing, and what they can do. So many people have no idea. So for these questions, if you have similar questions, please come here. I have prepared the answer, the soft copy about our company. I don't want to repeat this this part. Okay, it's very easy. And because actually what I want to say that in the coming video and our presentation, there is almost nothing about our company, even our production. But the video actually is for our CTC3 system. Yeah, I know that for Indian Railway, we chose the ETC as level 2, but it's a similar for CTC3, a similar system and same level. But anyway, for him, I don't reject any choice. Maybe in the future, we can try. We are here, we'll stay here, and we'll do our best for railway, Indian Railway, and the Indian people. And for our presentation, actually, you see that it's technical and application of Chinese railway. Through this presentation, we can know about Chinese railway, what had happened, and what happening, and what will happen. Thanks for your time. Okay, namaste. It's time for our export ministry. It's your turn. Oh, sorry. Video. Okay, it's a similar video. It's a very short video, only 5 minutes. So please. Sorry.
CTCS3 system is the core safety equipment to ensure safe operation and improve transport efficiency. The CTCS3 system has been applied to Beijing to Shanghai HSR with the longest mileage and highest design operation speed in the world. This proves China's train control technology has come to the forefront in the world. Now, let's start a journey to explore CTCS3 system. CTCS3 system consists of onboard and wayside subsystem. The onboard equipment includes man-machine interface MMI, vital computer VC, GSM, radio transmission unit RTU, speed and distance processing unit SDU, that is a transmission module PTM, and tri-circuit reader TCR. The wayside outdoor equipment includes ZPW2000 tri-circuit, Banister and GSM radio base station BTX. The wayside indoor equipment includes radio block center RBC, train control center TCC, temporary speed restriction server TSRS, computer-based interlocking CBI, GSMR mobile switch center MSC, and centralized traffic control CTC. According to the operation schedule, CTC automatically generates train route lists. CBI sets destination train routes based on this list and sends route information to RBC and TCC through signaling vital data network. The movement authority MA is generated by RBC and TCC and then transmitted to the onboard equipment through DXMR network, ZPW2000 track circuit and Banister respectively. According to the MA, the onboard equipment generates the distance to goal speed profile to supervise train operation. The MA can extend up to 32 kilometers and guarantee safe and high-speed train operation. CTCS3 system is integrated with the functions of CTCS2 system to realize the cross-line operation of both systems. CTCS2 is the fallback mode of CTCS3. In case of radio timeout, the train control system will automatically fall back to CTCS2 without train stop and continue to supervise safe and high-speed train operation. CTCS3 system realizes the integrated management of TSR in CTCS2 and CTCS3 in bad weather situations such as wind, rain, and snow, and under the circumstance of construction. Dispatcher will release a TSR for the TSRS to conduct centralized reception and management. Then, the TSR will be sent to relevant RPC and TCC and transmitted to onboard equipment through GSM-R radio network and Banister to automatically control the train operation under the restricted speed. CTCS3 system realizes bidirectional communication between onboard and wayside equipment through GSM-R network. With overlap redundant coverage technology of GSM-R network, the reliability and anti-interference performance of the system are improved. CTCS3 system can meet the requirement of train operation and a maximum speed of 300 kilometers per hour and above, and with 3-minute headway. What's more, the CTCS3 technical specification system has been completely established. CRSC has summarized a great deal of experience, mastered the leading-edge technologies in the safety control areas. Researched and developed a safe, reliable, technologically advanced, and autonomously controllable CTCS3 system with completely independent intellectual property rights and achieved its industrialization, can support sustainable development and the going global strategy of the HSR technologies. Looking into the future development trend of high-speed railways in China and the world, CTCS3 system surely will make further and greater contribution to the development of HSRs in China and the world, and the strategy of one belt and one road.
Good evening, ladies and gentlemen. It's a so long day, right? My name is Cui Junfeng. I'm the Chief Engineer of Signaling Department of CRC. Today, I'm honored to have the opportunity to present the technical and application of Chinese railway signaling system. First, a very brief introduction of the CRC. Founded in 1953, and the headquarters at Beijing, China, listed on the Hong Kong Stock Exchange, and we have more than 15,000 employees, and the revenue of 2018 is $5.9 billion US, and because we are the company specialized in the signaling and communication. In terms of the signaling business, I think we are the world largest solution provider for the rail control system. CRC can provide the full range signaling solution for the high-speed railway, commercial line, freight line, and our product and system widely used in the high-speed railway, the freight line, and the subway, maglev line, tram, and the light rail. And CRC also can provide the full life cycle project, including the R&D, engineering, design, manufacture, R&D, and construction and maintenance. Today, there are five parts in my presentation. First is the present status and future planning of the Chinese railway. The total operation length of Chinese railway has reached 131,000 kilometers, among which the high-speed railway's length is 30,000 kilometers, accounting for more than 60% of the high-speed railway around the world. So I can say today, China has already established the longest and the fastest high-speed railway network in the world. This is some numbers about the passenger transportation. In last year, 2018, the total number of the railway passengers in China was 3.3 billion, and the cumulative number of passengers traveled by high-speed railway since 2007 has reached 9 billion. And take the Beijing to Shanghai high-speed railway as an example. Beijing is the largest city. Beijing is the largest city in China, and Shanghai is the second largest city in China. And this one, the accumulated number of passengers has reached 0.8 billion. And with the average annual increase rate is more than 20%. This is the number of locomotive and the EMU in China. By end of the last year, the number of the railway, the locomotive number was more than 21,000. And the number of the EMU, the high-speed rail train, is 2,800, which leads the world. And more than 6% of the operating passengers was undertaken by the high-speed train in China. So the high-speed railway has become the main mode of the transport for the Chinese traveler. That the people, they like to choose the high-speed railway for the traveling. Yeah, this is the future plan of the Chinese railway. According to the medium and the long-term rail network planning approved by the State Council of China, by the end of 2025, the total operating length of the Chinese railway will be 175,000 kilometers, among which the high-speed railway network will reach 38,000 kilometers. That part I want to share the history of the evolution of Chinese railway signaling system. In general, the Chinese railway signaling system evolution can be divided into three phases. The first phase is the starting phase. The second is the speed up phase, and the third is the high-speed railway phase. In 1949, the People's Republic of China was founded, and at that time, the network length is 21,000 kilometers in China, and for the signaling, the main method is a point operated by the lever and the mechanical semaphore signal. And in 1959, the first centralized relay interlocking was opened in Beijing. And in 1991, I think this time is very close to India, is the first EI, or we call it the computer-based interlocking, was opened in Guangdong province. I remember the first EI was opened in 1990 in India. Yeah. And from the 1997 to 2006, this year, China had carried out 6 times speed up, and after the 6 times speed up, the Chinese railway signal is improved before the speed up, and most of stations adopt relay locking. And the block method 3FS automatic block, and the departure they need to manually set the routes, and there's no onboard equipment, no ATP for the operation, and the driver needs to drive the train outside. And at that time, the running speed is very low. The average travel speed is about 50 kilometers per hour, and there was almost no monitoring device. After the 6 times speed up and the computer-based interlocking are widely used in the mainland, and the 4-aspect automatic block method became the mainstream of the mainland, and we use the TDCS is similar to the TMS in India and the CTC to achieve the automatic dispatching. And we also to adopt the type signal LPG, AKG, kind of ATP, and ATP, to protect the train safety operation. And the running speed improved greatly, and the maximum running speed is 160 km per hour. And the centralized signaling monitoring system are widely used in China. In 2007, the first the CTCS is Hefei to Wuhan high-speed railway is opened. The running speed is 250 km per hour. And in 2009, the first CTCLF3 and is compatible with the EDCS. The CTCLF3 high-speed railway is opened from Wuhan to Guangzhou. The running speed is 350 km per hour. Next, I will introduce the Chinese railway signaling system and application. In general, the Chinese railway signaling system is mainly include interlocking, section block, train control system, traffic control system, centralized signal monitoring system, and the marching yard control system, automation system. This status the station interlocking. By the end of 2007, there are total 7,993 operating stations in China Railway. Among it, 76% is CPI, is computer-based interlocking, and the remaining 24% is relay interlocking. And the 6% of the total length adopts the automatic signaling, automatic block method. We call it ZPW 2000. This is the joint-list track circuit. 99 lecture is provided by the CRC. And the CTC and the TDCS are the two major traffic controls adopted by the Chinese New Railway. And the total rate is more than 90%. And the CTC is the percentage is 31, and the TDCS is 60%, and the CTC is all the high-speed railway adopt the CTC, and the TDCS is usually used for the traditional railway. The left one is the TDCS. Its function is like the TMS system. Its function include the train display, train diagram measurement, and automatic train ID tracking. And the CTC is, I think everybody is very familiar with CTC. It's the automatic adjustment of the train time schedule, and it can also be achieved with the automatic route setting. Next is the CSM. CSM is the centralized signal monitoring system. Is a comprehensive monitoring and maintenance system for the railway signaling, monitoring all the device including the locking, train control system, CT cell, power supply, everything. And more than 87% station has been equipped with CSL. And this is a marching yard. Yeah, in China we use we call it the CIPS, Comprehensive Integrated Automation System. Is a system composed of control, management, and information. I take the Zhengzhou North Station as an example. This is the largest marching yard in China, and it will process 36,000 cars per day. And the last part is this part is about Chinese train control system. In 2004, and the Ministry of the China Railway, they established the CTCS train control system, and it's divided into 5 levels. The CTCS level 0 and the CTCS level 1. These 2 levels is designed for the conventional line. The running speed is about 160 km/h. And the CTCL level 2 and the CTCL level 3, these two levels is designed for the high-speed railway. The running speed is above 250. And the CTCL level 4, this is the control system for the future. Is based on the radio transmission, no track circuit. It's based on the satellites and moving block. The low cost and more efficiency. And when we design the CTCS, we follow this principle. The principle is incremental updates and backward compatibility. Taking example of take CTCS level 2 as an example. For the wayside, we based on the police and the TCC, we add the RBC and the GMSR. And for the onboard, we add the GMSR mobile terminal and also update all the software. And CTCS level 2 will update to the CTCS level 3 and achieve the train control based on the radio. And the running speed also will be improved from the 300 to 350. And also, CTCS level 3 will fall back to CTCS level 2 when the radio timeout. Yeah, because when we design the CTCS system, we also consider the compatibility with the ETCS. There are some certain equivalence relationship between the CTCS and the ETCS. And for the CTCS level 2, because CTCS level 2 is based on the track circuit and the beliefs, so it's similar to the ETCS level 1, is not equal to ETCS level 1. But the CTCS level 3, yeah, is based on the radio. It is compatible with the ETCS level 2. Yeah, here, maybe I can go to some detail of the CTCS level 2. There are some, this is the onboard improvements. This is the wayside improvements. For the wayside, we have the temporary speed restriction service. Yeah. And here, very brief demonstration about how the CTCS level 2 works. First, the track circuit will detect the train occupancy and also detect the broken rail. And also, in the CTCS level 2, we also will provide the moving authority by the track circuit. The track circuit will provide the number of the block free ahead. If L5, that means H block free ahead. And police will provide the TSR user information and also provide the line profile, SSP gradient, and the length of the block. Then the onboard will based on this information to calculate the brake curve, then supervise the train running. This is the season level 3. Is the running speed is about 300 km per hour, and take the CZ level 2 at the fallback. This is the this is a key feature for the CZ level 2 because the radio sometimes it will be disturbed. That in the radio timeouts in China, the train will go back to the CZ level 2 automatically without stop. They will save a lot of time and keep the efficiency of the line. This is the brief demonstration of how the CZ level 3 works. Train reports the transportation and the RBC based on the route information and the train frequency information and the TSR, and generate the MA, and the train based on the MA calculate breaker to supervise the train running. Yeah, this is all the equipment related to the CZ level 3. Yeah, and CZ level equipment, the composition and the usage are consistent with the ETC level 2. The RBC, ADP, LEU, balance are certified CO4, and also the TSI. TSI is the technical specification of interoperability certified by the Europe third party. Yeah, some feature of the CZ level 3 is very mature and widely used in China. Now the mass CZ level 3 is 16,000 kilometers, and the maximum speed is 350, and the headway is 3 minutes. This is the timetable. Yeah, in the peak hour. And because China have different the weather type, so our equipment have a strong environment adaptation. We can use in the high temperature, high humidity, and high mist environment. We also can use in the west of China, windy, sandy desert area. And in the north of the China, in the extreme cold, we can run the train in the -40. Yeah, and the CTC level 3 will also support the mixed transportation and also can equip on the EMU of the locomotive. This is the high reliability of CZ level 3. In China, the train stop rate caused by the fault of the signal system is 0.37 per million kilometer, and the departure punctuality is 98.8%, and the arrival punctuality is 95.4%. Yeah, next I want to share some, we think the most important for the, to ensure the rapid and the safe development of the high-speed railway. Yeah, because the CRC involves the design and the construction of the high-speed railway from the beginning. So first, we think the most important thing is the system design. China has established a comprehensive standard system of CTC level 3, which covering the whole system life cycle. Yeah, there are things from the system design, engineering design, product manufacture, construction, test acceptance, and the operation and maintenance. Okay. This is the map of CC3 specification, and yeah, our product is follow a script, the RAMS design principle, 2x12 EMC design, gate design, and this is the product list we can provide by CRC, automation and the vital automation, communication, and the signaling. Yeah, this is the factory and product line. We also prepare and manage all the specification on behalf of the China Railway. We have the very detailed internal operation manual. This is some picture from the field, the beam design of the scheduled relay room, and the wiring and installation of equipment. Yeah, the last one is system integration. Before going to operation, there are very strict lab test procedure and the metaphor test, on-site test. After all this is qualified, then we'll have a system integrated commissioning in the field. Now, there are totally 30,000 test cases in our lab. I think this is a large number in the world. And also, all the test cases can carry out by the automatic test environment. This is our lab. And just Mr. Suri already mentioned, our market share is more than 90%. It's not 90, 90%. 90%. As the last part, I want to share some prospects of China within system. The first one is ATO. We opened the CTC2 plus ATO in 2016, and the running speed is 200 kilometers per hour. And we also achieved 350 kilometer ATO in the last year. We have tested in the field test in Shenyang, Beijing to Shenyang has railway, and the grid of the automation is GOA2. And the GO4 is widely used in China in the metro. Yeah, this is the structure is CTC3 plus ATO. And next is the RTR. China Railway, we launched our reservoir from the 2010, and we released all the release function requirements in the 2007, and we carry out the field test in the last year, and according to plan, we will release the whole specification set this year. And this is some picture from the field. Yeah, this is the pilot plan. The length is 160 and the 5 station. And the test speed is 350 km per hour. And this test is carried out and specified by the CRC. And from the test, we can see the RTE, the high-speed adaptation, the carrier capability is verified in the field. You can fulfill the application of the application. Yeah. Yeah, I think that's all for today. Thank you.
Thank you very much. After such a long day, starting from 9 o'clock today, it was really very hectic, but it was really thoroughly enriched. A lot of experts have come today and shared their wisdom, knowledge, our own experience from the railway, which is normally very difficult to find, and find all those who are experienced railwaymen and sharing their ideas with us, and a lot of experts from the industry. In fact, the same is lined up. Tomorrow AM Signal is coming, and he will start the day at 9:30, and other board members, MRS, MS, ME, and FC, all those will be addressing tomorrow in the first half through VC. And besides that, other industry leaders will also come with our own railway. So tomorrow is also full pack. First half, mostly we'll try to conclude ourselves in the first half itself. And so we'll call it off today. And at 8 o'clock, in front of the palace, Rajaba, there is a dinner is organized. You're cordially invited. Everybody is cordially invited. Please do come. Thank you. Thank you very much. 9:30. Tomorrow 9:30 we'll start. बोल दिया